One, if you have a sine of, let's say, two angles, A plus B, sum of two angles, then this can be written as sine of A times cosine of B plus cosine of A sine of B. So that's our formula for sum of two angles for sine. Then we also have one for difference. So if you were to just replace this with the difference, you get this formula. So you have sine of A minus B. So this will still be the almost identical to the previous problem, a previous formula. It will look sine of A cosine of B, but a minus and then cosine of A sine of B. So I'm just going to copy and paste so that way you can see how these formulas are almost identical, except their differences right here. Right, that's where they're different. Then we have two more for cosine of sum and difference of two angles. So for cosine, we have the following ones. So if you're looking at, let's call this our third formula. So if you're looking for cosine of A plus B, this is equal to cosine of A times cosine of B minus sine of A times sine of B. That's the formula for cosine of sum of two angles. And lastly, if you have cosine of A minus B, so again, difference of two angles, A and B are considered angles. This will be again identical terms, cosine of A, cosine of B, but with the plus sign between the terms, sine of A and sine of B. So once you know these formulas, then working out some examples, it's pretty easy, not so difficult. Here's an example for you. We want to find the exact value of sine of 15 degrees. So we know that 15 degrees you can rewrite as sum of two familiar angles. So for example, you can write sine of 15 degrees as sine of sum of two angles or difference of two angles. So in this case, it looks like if I take 45 minus 30, I get 15 degrees. So all I did is replace the angle with a difference of two angles that I already know their exact value of for sine or cosine. Now, once you have selected your angles and the sign between them, in this case, we're doing 45 minus 30. So you can think of this as your A value, this is your B. Now, using the formula above, we can evaluate. So let's go ahead and write that down. So since we're doing difference, we're going to be using the second formula. So I'm going to go ahead and replace that right here. And I'm going to replace the angles with what we have. So I hope you're understanding what's going on here. So my A happens to be in this problem 45. So this will be sine 45. B is 30, cosine of 30 degrees. And then cosine of 45 times sine of 30. So I just replaced the angles where A and B are in the formula. And now we go ahead and evaluate from our memory. We know sine 45 is square root of 2 over 2. Cosine 30 is square root of 3 over 2. And cosine 45 is square root of 2 over 2. Sine 30 is 1/2. So those are the exact values. And now we just perform the multiplication. We get square root of 6 for square root of 2 times square root of 3 over 2 times 2, that's 4, minus square root of 2 over 4. So you can leave your answer right here in this exact format, or if you want, you can combine them since they have same denominator. This can be written as square root of 6 minus square root of 2 over 4. So that will be our answer to this particular example. Here's another example. We want to find the exact value of cosine of 165 degrees. Now, this isn't so obvious if you're going to use sum or difference of two angles, because here our angle happens to be greater than 90 degrees. So first thing you need to do is find the reference angle for this. We're going to go ahead and make a sketch. So here's our plane 165 degree terminates right here. So this is 165 degrees, which means I can find the reference angle, which is this angle right here. So that means our reference angle for 165 is going to be 180 minus 165. If you need help with reference angle, I will leave a link in the description box for you to check it out. Now, once I perform these subtractions, I get 15 degrees. All right, so we're good to go now. Now we do need to remember that once you're beyond the first quadrant, your values of the trig functions might change, the sign of it, depending on which quadrant we're in. So remember this acronym, ASTC, meaning if you're on the second quadrant, only sine is positive or cosecant, its reciprocal, are positive. That means for cosine, we need to put a negative sign in front of it. So here's how you're going to do this. So we know that cosine of 165 degrees is equal to negative cosine of 15 degrees. That's how you replace it. Because we're in the second quadrant, so we do need to consider is the value of that angle for cosine positive or negative. Okay, now we just rewrite this angle just like we did before. We know that 15 degrees can be rewritten in one of this ways. So you can write this as, again, 45 degrees minus 30 degrees. That's my selection of angles. You could have picked another pair. It doesn't have to be 45 and 30 as long as they give you 15 degrees at the end. Now let's go ahead and evaluate using the formula. So we know that, so again, give yourself a quick recall. If you have cosine, now here we're looking at a difference, A minus B, two angles. This is equivalent to cosine of A times cosine of B plus sine of A, sine of B. That's the formula we're going to remember. Now let's go ahead and do that. So this is our A, this is our B. We have a difference in the middle. That's the formula we're going to use. So this is equivalent to negative from before. We do cosine of A, which is 45. Then cosine of 30 degrees plus sine of 45 degrees times sine of 30 degrees. So I'm just using this formula to expand. All right, now from our memory, we evaluate these values. So we know negative cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2 plus sine 45, that's square root of 2 over 2. Sine 30 is 1/2. All right, and then if you multiply them out, this will give you a negative square root of 6 over 4 plus square root of 2 over 4. Now, if you want, you can leave your answer right here because this is considered exact value, or you can distribute out the negative sign to each of these terms, and you'll have your answer as negative square root of 6 minus square root of 2 over 4. You could also leave it like this. Either of these are fine. Okay, I hope you understand how to use the sum and difference formulas for sine and cosine.